Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for DMA 050. The purpose of this video is to show students how to graph linear equations using intercepts, x-intercepts and y-intercepts. So what is an intercept? An x-intercept is the point or ordered pair in which the graph of the linear equation crosses the x-axis. So where the line or graph of the linear equation intercepts the x-axis, hence the name x-intercept. And the y-intercept is where the line or graph of the linear equation crosses the y-axis. Hence the name, once again, y-intercept, where the line intercepts the y-axis. Okay, so we're going to start out with a linear equation here, negative x plus 2y equals 6. If you have a linear equation in which the x and the y are both on one side of the equation, it really lends itself nicely to finding the x and y intercepts, in which we can then use those to, of course, graph the equation. So once again, we're going to start out here with a table of ordered pairs. Okay. And so let's take a look at our xy coordinate plane. So if we look at a xy coordinate plane, any place where our line crosses the x-axis is what we call our x-intercept. Well, any point on the x-axis is going to have a y-coordinate of 0. This point here is 1, 0, 2, 0, 3, 0. Over here, negative 1, 0, negative 2, 0, negative 3, 0. So to find the point in which the line crosses the x-axis, we would want to substitute 0 in as the y-coordinate. Okay, so let's do that. So plug 0 in for y, and that's going to give us our x-intercept. Okay. So plug 0 in for y into our equation, solve for x, and that should tell us the point in which our graph crosses the x-axis. So 2 times 0 is, of course, 0. So we get negative x equals 6, and remember there's a negative 1 there. So divide by negative 1 on both sides, and we get x equals negative 6. So then our x-intercept is negative 6, 0. So if we go back to our graph, this is our equation, negative x plus 2y equals 6. So the point negative 6, 0 is located here. So that is where our graph is going to cross the x-axis, or is the otherwise known as the x-intercept. Okay, so that's one of the intercepts. Let's find the y-intercept. Okay, so keep on our graph here. The y-intercept is where our graph crosses the y-axis. Well, if we think about the vertical axis, which is the y-axis, right, every point on this y-axis has an x-coordinate of 0. This is the point 0, 1, 0, 2, 0, 3, 0, negative 1, 0, negative 2. So if we plug 0 in for x as the x-coordinate and solve for y, that will then give us the corresponding y-intercept. So we're going to plug 0 in for x. This is going to be our y-intercept. So it may seem a little backwards because we plug 0 in for y to get the x-intercept, and we plug 0 in for x to get the y-intercept. But when you think about it graphically, hopefully it makes sense. Okay, so let's solve our equation to try to find our y-intercept. So in this case, I'm going to put 0 in for y, or I'm sorry, excuse me, 0 in for x. So then, obviously, negative 0, that's going to be 0. We're not going to worry about that. So 2y equals 6. Divide both sides by 2. Y equals 3. So then, that is our y-intercept, 0, 3. So let's graph that on our graph. So 0, 3 is here. Okay, so technically that's enough to graph a line. I mean, like I said before, we only need 2 points to graph a line. We have 2 points, right? So we could connect those dots and draw the line. However, it is nice to have a test point just in case we messed up somewhere along the way. So let's do a third point, a test point. And once again, I can choose any x coordinate or y coordinate to plug in here. I want to make sure that I pick something that is going to be easy to work with. So I'm looking at this x here, and I know that if I plug in a number for that, it's going to be negative, and I'm going to have to add it to the other side. And as long as this is even over here, it's going to be divisible by 2, and I'm not going to have a fraction. So let's put a 2 in there. So zoom out a little bit. So let's try 2 as our x coordinate. So if I plug in a 2 there, I'm going to get negative 2 plus 2y equals 6. And of course, I'm going to add 2 to both sides, which is going to give me 8, which is even. That's why I chose 2. So now I can divide both sides by 2, and I get y equals 4. So that works out nice. I get a nice whole number, no fractions, and it's relatively small, so I don't have any crazy numbers or ordered pairs that I have to graph. Okay. So now 2, 4 should lie on that line. So let's just see what happens. If it doesn't, then we need to go back and check our work somewhere. So we've got our y-intercept, we've got our x-intercept. So let's plot the point 2, 4, which is right here. And yes, that does line up with our other 2 points. So we can then connect those to form the equation of the line. So graphing with intercepts is actually really nice and easy, especially if you have this set up where x and y are both on the same side. It is also helpful that these coefficients divide into this constant on the other side evenly. That way we don't have any fractions. Alright, so let's take a look at another example. Alright, so y equals negative 2x. Now in this case, x and y are not both on the same side of the equation. So I'm going to find my x and y intercepts. So to find the x-intercept, plug 0 in for y. To find the y-intercept, plug 0 in for x. Excuse me. So let's do that. So let's plug 0 in for y. Solve for x. So 0 equals negative 2x. Divide by negative 2. Divide by negative 2. So 0 equals x. So then that is our x-intercept, 0, 0. Let's find our y-intercept. So let's plug 0 in for x. So when I do that, negative 2 times 0 is 0. Ooh, I get the same thing. Why is that? The x and y-intercept are the same. Well, remember, 0, 0 is a special point on our x, y coordinate plane. That's the origin, right? And the origin lies at the intersection point of both of these number lines. So the point 0, 0 is right here. That's the origin. So if I'm at the origin, I'm on both axes. So that is why that one point is the x-intercept and the y-intercept. If I'm at that point, I'm on both. So that's where my graph intersects both axes at the exact same time. So obviously I cannot graph a line with just one point. So let's go back to our table, find at least one more point. And notice that this equation is solved for y, so it makes it really convenient if I just plug in numbers for x here. I can then find the corresponding y coordinate pretty easily. So I'm going to try to make this easy. Let's just use 1 for x. So if I plug 1 in for x here, then I get negative 2 times 1, which is negative 2. So then that ordered pair is going to be 1, negative 2. And that point, 1, negative 2, is located right here. And we technically could stop there, but like I said, if I fix one of these points, I can move this point basically anywhere and form a line, and I don't really know if that line is correct that matches this equation. So let's do another point just to be sure that we've got the right line. So running out of space here. Let's do another row on our table. Do something pretty easy here. Continue to plug numbers in for x. Let's just do 2. It's a nice easy number to work with. So if I plug y equals negative 2 times 2, I get y equals negative 4. And of course, that matches with 2 to give me my ordered pair. So 2, negative 4 should be on this graph. So 2, negative 4 is right here. And lo and behold, that does lie on that line. And then we can connect those dots to graph the line. All right. And last but not least, we've got an equation with some fractions. And so we do our table. And let's graph this with intercepts once again. If our directions specifically say to graph with intercepts, we must graph with intercepts. So even though there are other methods for graphing this line, if it calls for intercepts, if those points are not on my graph, that can be counted incorrect. So let's make sure that we do that. So if I plug 0 in for y, that gives me the x-intercept. If I plug 0 in for x, that gives me the y-intercept. Okay. Zoom out a little bit here. Okay, so let's plug 0 in for y to begin with. Okay, so I get 0 equals negative 2/3 x plus 1, and we want to solve that for x, so we're going to subtract 1, subtract 1. So negative 1 equals negative 2/3 x. And then recall that we can eliminate that fraction by multiplying by the reciprocal of this fraction, and the reciprocal is just flipping the fraction. So the reciprocal of negative 2/3 would be negative 3/2. So if I multiply by negative 3/2, that's going to give me 6/6, which is 1, so 1x. And then, of course, whatever I do to one side, I need to do the same thing to the other. So I'm going to write negative 1 as negative 1/1 times negative 3/2. And I end up getting positive 3/2. And, of course, 3/2 is the same as 1.5. So we actually do have some fractions here, but that's okay. The problem specifically says find the intercept. So these intercepts happen to have fractions. So if you're doing this on my math lab, this graph should give you the half marks so that you can actually plot this. Finding the y-intercept, we're going to plug 0 in for x. So y equals negative 2/3 times 0 plus 1. And this one's going to work out much nicer because negative 2/3 times 0 is obviously 0. And 0 plus 1 is equal to 1. So that works out really nice. Okay. And then let's do a test point. Just to get that third point in there. Remember, if I'm dealing with fractions here, I want to multiply by that denominator or multiples of that denominator. So let's use 3. Okay. So if I plug 3 in for x, y equals negative 2/3 times 3. That's negative 2/3 times 3/1, which is negative 6/3, which is negative 2. So negative 2 plus 1 is negative 1. Okay, so a little bit of fraction work there. So let's go back up here. And that gives us our intercepts, and then it also gives us a test point. So let's plot that. So we've got our equation, y equals negative 2/3 x plus 1. So our 3 points is 1.5, comma 0. That's our x-intercept. So 1.5 is going to be between 1 and 2 here. So there we got that point. 0, 1. That's our y-intercept. So that's here. And then our test point, 3, negative 1, just to make sure that lines up with the other two, and it does. Okay, so then let's graph that line connecting our dots, and that should give us the graph of that linear equation. All right, so that's a few examples of how to graph linear equations with x and y intercepts. Once again, if you have any questions, please email or stop by the office. Have a great day.